Okie dokies, artichokes, let's get started. I'm just going to move my mic up a little bit. Awesome. So today we're going to be looking at different types of data. So at the top here, we're going to take a look at what's called a pie chart. You might be familiar with pie charts from elementary school. These are really common, normally very colorful. My teachers used to call it a pizza chart because it kind of looks like a pizza. Also a pie. So a pie chart is a good example of what we call, in the math world, single variable data. Because a pie chart can only display one set of data, and it's meant to display only one set of data. So for example here, this is displaying the populations in each continent. Okay, so for instance, Asia takes up about 54% of the world's population. Europe takes about 22%, North America takes about 7%, which is where we live. Africa takes about 9%, and so on and so on. This is specifically looking at the year 1950. What were the populations at the time? So a pie chart is a good example of single variable data because all I'm looking at here is population, not populations and deaths, not populations and illness. I'm only looking at population. If we come down to this table, you guys should be pretty familiar with tables. This is a good example of what we call bivariate data. So bivariate data is simply a fancy word for two variable data, meaning I have two variables that I'm looking at. In this case, my first variable is odometer readings. My second variable is price. So in case you don't know, an odometer reading basically is the number of miles your car has driven. Okay? When we do bivariate data, we're typically trying to compare two variables together. In this case, I'm trying to see if odometer reading has anything to do with the price of the car, or if the price of the car has anything to do with the current odometer reading. Single variable data is not meant for comparing because I only have one thing I'm looking at. I'm not trying to compare anything. I'm just saying, look, populations, woo! Here, I'm going, I wonder if odometer reading has anything to do with price. And the way we find that out is we graph it on what's called a scatter plot. Scatter plot. Okay? So I'm going to take my data here, which remember is in sets of coordinates, right? 35, 38 is a coordinate. We're going to let the x-axis be the odometer reading. And we're going to let the y-axis be price. Okay, so I'm going to go through and I'm going to plot each of my points. So my first point is 35, 38. So this is 35 going up to about 38. My next one is 55, 16. So we're going to go over to 55, up to about 16 and put a dot. Then 650, right about here, up to 50. Now, you may be looking at this and being like, wow, those dots are all over the place. Yes, they are. Keep graphing. I promise it's going to make sense as we go. So, 28, 30, right there, 50, 26, 31, ooh, that's a tricky one, 35, 15, 28, 99, and 10, and 99 and 13. Okay, so if we take a look at our dots, let me see if I can get this a little closer to us. There we go, and focused. So if you take a look at my dots are all over the place. So the key word for this is scatter. Right? If you take something and scatter it, you're just throwing it around, it's going to be random. They're supposed to be random. Please, 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 I cannot stress this enough, do not connect your dots. Don't do it. A scatter plot is supposed to be random. Don't connect the dots. This is how they're supposed to look. Okay? What a scatter plot does for us that one of our linear graphs, so our just straight lines, doesn't do for us is it gets to show us a bunch of data that might vary. Doesn't all follow the same pattern. But there is a pattern. So if you notice, my dots are kind of trending down, right? Down, down, down we go. I can use the scatter plot to compare my two variables. Is odometer reading connected to price? I want you to look at the scatter plot and answer that question on Nearpod. Do you think the higher odometer reading or lower odometer reading is connected to the price of the car? Okay, stay tuned to see if you're right. So if we take a look at our odometer readings, this dot right here is an odometer reading of 6, so that is 6,000 miles. That car is practically brand new. And that car costs about $50,000. That's a lot of money. If we go over to the very farthest, we have cars that have 99,000 on them. That's still not a lot of miles. And these cars cost about $10,000 and $13,000 respectively. Okay? Meaning, if we take a look, the lower the odometer reading, the higher the price. And as the odometer reading gets higher and higher and higher, the price goes down. So, do odometer reading and price have something in common? They do. Higher the odometer reading, lower the price. If you think about it, the older a car is, the less you typically have to pay for that car. So, that's an example of bivariate data. Now I want to show you something really quick that's kind of cool. You guys might be familiar with these. These are called box and whisker plots, and I kind of did that one wrong. Let's see if I can fix it. There you go. So a box and whisker plot is another example of something that is meant to show single variable data. I had to make two box and whisker plots because they each only show one set of data. So one's odometer and one's price. Taking a look at these box and whisker plots, could you have told me that odometer reading has anything to do with price? Probably not. I couldn't. Because there's no connection, and there's not supposed to be. Single variable data, things like box and whiskers and pie charts, are not supposed to compare two sets of data. They're just supposed to display one set of data. But a table and a scatter plot are specifically supposed to show you at least two sets of data, aka bivariate data. In this chapter, we're going to explore a lot of bivariate data, and we're going to use scatter plots and tables to compare them. So in this lesson today, you guys are going to have 5 teams that have taken data on plant growth and what affects it. You're going to create 5 scatter plots, and based on those scatter plots, you're going to see, do each of those teams and the specific things they looked at have anything in common? Is there a comparison to be made? Keep that data around though, because we're going to use it on another lesson to see if we can give a general name for that. Okay guys, have a great day. I will see you in the next video. Bye.